Hi everybody, I'm the greatest living inventor, and today we are doing my invention, ferromagnetic glass micro pearls. Let me write it down. Ferromagnetic glass micro pearls. I'll just take off my jacket. See, it's a new shirt with the Darwin. See, like the more evolved you are, the more you become like a Darwin. And okay, so an environmental friendly substitute for plastic packaging. Okay. Imagine a new kind of smart material that has all the good qualities of plastic: flexible, airtight, transparent, durable, but have none of the bad qualities of plastic: pollution, dangerous chemicals, flammable, hard to retrieve and recycle. How does it work? Firstly, we need to understand what ferromagnetic means. It means a material like iron. Okay, so for example, iron. Okay, iron, example of ferromagnetic. Which means it can be magnetized. It means a material like iron that if you put it inside the magnetic field of a big magnet, it becomes a little magnet. Then, even after you take away the big magnet, the little magnet stays magnetic. I'll just close the air condition, sorry. So this happens because we gave time for all the little parts in the iron to align in the same direction. If we change the direction of the big magnet fast, then the iron stops being a magnet. Let's call this demagnetized. Okay, so iron can be magnetized. And it also can be demagnetized. Okay, if all the little parts inside the iron are made to be in the same direction, Okay. Then it's magnetized. Let's say this is the north, this is the south. If it's each particle has another direction, then it's demagnetized. Okay, it's like it's not magnetized. Okay, imagine if the iron is made microscopically of some particles, like every atom in the every bunch of atoms can be in the same direction, or it can be in a different direction, and then it's not magnetized. D means not. Okay. So, secondly, we need to understand how little ball-shaped magnets behave when they are put together in large numbers. They behave just like magnetic toys. Important note, packaging balls or on the micro scale, less than a millimeter, so they are not dangerous, swallowing a few. Also, there is, I'm just reading so I'll understand what I wrote, even though I read it before the recording. Anyway, it's not dangerous if you swallow a few of them, even if they are magnetized. And if they are demagnetized, you can swallow as much as they want. Okay, it's micro beads. Okay, like a millimeter big glass beads. But we'll talk about this. But even if you, I know I said iron, but it's coated with beads. That's why it's called pearls. So I'll explain later. But anyway, it's not like plastic, that if you swallow plastic, it's bad for you. It's an endocrine disruptor. It changes the hormones in the body. Here it just goes through you. Okay. So they are not dangerous, swallowing a few. Also, there is no danger in swallowing many after they are demagnetized, as will be described shortly. See in this video by Little Lady on YouTube, fun, colorful magnetic bead review. Okay, so it's a video. I will put it in the description. Little Lady. Fun, colorful magnetic bead review. Okay, so you can see how it, I will put the link in all the links in the description, but it's on YouTube, and you can see how they behave, the little magnets, and these are like 1 centimeter big, but if, or maybe less, I don't remember, like half a centimeter, 1 centimeter, something like this in diameter, and we are talking about 1 millimeter in diameter, so it's, but it behaves the same. Okay, so you should see it in macro scale and imagine it in micro scale. Notice when she stretches a film or ribbon of them and it's not torn. So imagine the same thing at a much smaller scale. So you can see why it will be flexible like plastic polymer. Thirdly, We don't want metal touching our food or whatever we package, so we are coating each little ball in glass. Okay, so this is the part of glass. This is why I'm calling it pearls. The tiny metal ball is like the nucleus, intruder or graft, and the glass coating is like the glistening pearl sac, calcium carbonate around it. Glass coating metal is possible. You can see here, glass coated wire in Wikipedia. Okay, glass coated wire. In Wikipedia. Our pearls are made in a factory in high heat, so the glass becomes soft but not the metal. Okay, this is like not completely accurate. Iron is melts in about melt in about 1500 degrees Celsius. Okay, and glass also melt at about 1500 degrees Celsius. Okay, so it's about the same, but like you see, it's possible to coat metal with glass, and you can play with the parameters a little of the alloy to make it higher or lower if you need, and also you can play with something that you add to the glass if needed. Okay, so our pearls are made in a factory in high heat, and the result is that when each tiny ball cools down, the metal which previously expanded in the heat becomes smaller, and so there is vacuum between the inner metal ball and the surrounding glass sphere. Okay, so it looks like this. Eventually it looks like metal surrounded by, let's make it purple, glass. Okay, glass. And between them okay, this part is a vacuum. Okay. Yes. Okay, so there is a vacuum between the inner metal ball and the surrounding glass sphere. Can you see the colors? Yes. Okay. This vacuum gives each ball the property of buoyancy, so it's easy to collect them from the surface of water. They just float there, and you pass a magnet above them and they jump up. Okay, if they get to the ocean eventually, which they shouldn't get, it's easy to collect them. They just float, you go up with a magnet and collect them. This vacuum gives each ball the property of buoyancy. Okay, I've read this. The glass coating needs to be thick enough to withstand such blows and also the air pressure on the inner semi-vacuum. Semi because it's not an empty glass sphere, instead some of the volume inside is occupied by the metal ball. A sphere shape resists pressure from the outside very well. This is why submarines going to the ocean's abyss look like spheres. Okay, so I'm just making the glass thicker. So it can withstand the pressure from the outside and the blows from the outside. Okay. By the way, we can also make the iron hollow. It depends how much magnetic we want it. Maybe we can achieve the enough effect with the iron being hollow and not a solid field, and then it's lighter. Okay, we can magnetize a sphere also. Okay, so now finally we have all the parts of our building block. So let's see how we use it in everyday life. Okay, so remember this, we have this whole thing is like 1 millimeter. Okay, and in diameter, and we have lots of this. Each one is called a pearl. Okay, so many pearls. So let's see how it's used, how they are used. And remember the magnetized and demagnetized. This is when it behaves like a magnet, and this is after we demagnetized it, then it's not behaving like a magnet. Okay, I'm erasing everything. Okay, I'll just drink something. Okay, 18 minutes. Okay, how it's used. At home. Okay, this is the first question. Let's say mom goes to the supermarket and buys an apple, which is individually wrapped in pearls. Okay, so imagine we have an apple. And the apple is wrapped in pearls. Okay, so I'm doing the pearls in purple. I'm not drawing in scale because it will be impossible, but I'm just drawing it as if it's 1 centimeter or something. But it's actually 1 millimeter, and it can be multi-layered. Okay, so mom bought this apple, and it's individually wrapped in pearls. So each one is like the pearl that we had here. Okay, inside is a tiny iron which can be magnetized. Now it's magnetized, so it holds together, and each pearl is holding to the other pearls, and this is why they hold on to the apple. Okay, so she comes home and puts it in the demagnetizer. Okay, so imagine that we have some machine, okay, like we have a microwave. Okay, like a microwave has this door, and you open the door and you put your food inside. Okay, this is a microwave. Okay, so now imagine instead of the microwave, or in addition to the microwave, it's a kitchen, we have room. So in addition to the microwave, we have another thing that is called a demagnetizer. Let's see that I didn't write it wrong. Demagnetizer. Okay. And instead of heating food, you put inside the apple. Okay, like now we have the apple in here. With all the micro pearls. And then we close the doors. We open the door. We put the food, the apple, inside. Close the door. Turn it on. Okay, this is the on/off. And what it does, it demagnetizes. Okay, it's not hard to guess. It demagnetizes the food. So it does this action of removing the magnetization, so all the pearls fall away from the apple. Okay, and they collect here in the machine. Okay, so the machine has some tray that can collect them. Okay, so she comes home and puts it in the magnetizer. This is a machine that looks like a microwave. And also, like the box of the microwave, the magnetizer is a Faraday cage. So mom is outside and she is protected from the changing magnetic field inside. What happens inside the simple machine is this. If this is done in air, the pearls stop being magnetic and fall down to a collector. Okay, this is the collector. If this is done in water, then the pearls float up to a collector. Okay, remember they have this tiny vacuum inside, so they float. They are buoyant. So they float, and the machine collects them for us and stores them. Anyway, at the end of the process, mom opens the machine and takes out the unwrapped apple. Okay, so in the end of the process, mom has this apple without any purple. I'm trying not to draw this again. Okay, and anyway, at the end of the process, Mom opens the machine and takes out the unwrapped apple, and once a month she takes out the demagnetized pearls to the supermarket. Okay, so like once a month she had this bag of pearls. I don't know how to draw a bag. But all the pearls are inside. Okay, and she takes this to the supermarket, and the supermarket gives her some incentive for recycling, like with plastic. Okay, so this is how it's done at home. How is it used in the factory? So I'm erasing this. Okay, how is it used? How is it used in the factory? Let's say we own an apple factory. Okay, so we have a lot of apples. First, there is a central factory in every city that receives all the used pearls from the supermarkets, cleans them, like with boiling water, and magnetizes them again by putting in one layer and passing them between two ends of a strong electromagnet for a few hours. Okay, so there is a factory, a central magnetizing factory. This is not our Apple factory. Okay, we have the Apple factory. And this is something else. Okay, so this gets all the, it's a factory. And what it does, it takes all the pearls from everybody, put them in a layer, one layer, okay, I'm trying to draw something that is flat but has width and height. Okay, so it's like one layer. And puts them between a magnet. Okay, so they have a big magnet at the factory. Of course, it doesn't look like this, it's electromagnet, but it behaves the same in principle. Okay, so they magnetize the pearls, all the pearls. And also they clean them, okay? So cleaning. I don't know how to draw this. with boiling water. Okay, so now from this remagnetization, okay, this is remagnetization because these are not new pearls, these are recycled pearls. So these are remagnetization. Now from this remagnetization, the pearls are arranged in big cubes and sent to our pearl factory. Okay, so after this magnetization, out of this factory, there are like trucks or something. That have that contain cubes of pearls. Okay, big trucks. Okay, and this is our factory. And this is the Apple factory. And we have like a production line with apples, sorry, and we take this cube, okay, pearl cube, and we make a layer, okay, we cut a slice, okay, so this is a slice. Okay, it's like a knife. Of course it's automatic, but I'm drawing it like it's a hand knife. Okay, so this is a knife, and we cut a slice from the cube. Okay, there is the cube, and we cut one slice. And this slice is used afterwards to wrap an apple. And then another apple and another apple. Okay, so now from this remagnetization, the pearls are arranged in big cubes and sent to our apple factory. So here we peel the cubes into sheets. Okay, this is a sheet. Pearl sheet. Not cube. Okay, this is cube, and now we cut this into sheets. And so here we peel the cubes into sheets. It's really like slicing them. You can see here, it's very long. Jump to minute 5 if you are tired. This is a YouTube video that is called Playing with 60,000 Magnetic Balls, Slow Motion. Okay, playing with 60,000 magnetic balls, slow motion. And this is by 100 plus 1% satisfying video, blah blah, Magnet Master. Okay, so this is by Magnet Master. Okay, it's a nice video, but it's long, so go to minute 5. And there you can see that we can slice and the sheet holds together. Okay, this is done in macro scale, but this is in micro scale. Okay, so another cool thing to notice in the video is that even if the material is cut, okay, this is if he cuts just one slice, but if he cuts more in the middle, like 2 or 3 or whatever in the middle, jabs the knife, stabs the cube and the slices. So another cool thing to notice in the video is that even if the material is cut, like by accident in the delivery truck to the supermarket, okay, so in this delivery truck, okay, so if each apple is has around it a personal package, okay, which is not environmentally friendly if it's plastic, but if it's micro pearls from glass and the iron that are recycled, then it's perfectly fine. It's good to have it and this makes a hole in the package, so it immediately closes itself, okay, so it's like self healing. It automatically fixes itself. Okay, so once we have an isolated sheet, it behaves like plastic cling wrap at home. Okay, so this is like a plastic cling wrap that you wrap something with at home. We fold it over the item, the apple, and trim the excess edges. Okay, but of course it's made from an environmentally friendly thing because it's healthy if it touches the food, and it's recyclable, not like plastic. Okay, how it saves the earth. Okay, so I'm erasing this. Just seeing what time is it? 38 minutes. How does it save Earth? Even if pearls get to the ocean, they just pass through the animals. They are not endocrine disruptor like plastic. Okay, so if if we have the ocean, okay, they're not supposed to get to the ocean, but if they get to the ocean and there is some, fish, and the fish sees, first of all, they float. Okay, so we can collect them if they reach the ocean, which they shouldn't. But if they reach the ocean, it's very easy to bring a drone. Okay. With the magnet. Okay, this is a magnet, and it collects all the pearls easily because they float. But let's say even if some animal eats the glass pearls, okay, so it goes through the animal and comes out and doesn't harm the animal. It's not like plastic. Plastic, not like plastic. Why? Because plastic is an endocrine disruptor. Okay, so it damages the animals. And this doesn't damage the animals. Okay, so even if the pearls get to the ocean, they just pass through the animals. They are not endocrine disruptor like plastic. Also, if pearls get to the ocean, they float, and the low-flying drone with a magnet can collect them back cheaply. I hope by now you understand that the pearls are totally safe for the environment and for people, not like beads, for example, not like plastic beads. Okay, plastic beads, you can see in Wikipedia, environmental impact of Mardi Gras beads. Okay, so this is beads are made, these plastic beads are made from polyethylene and polystyrene, and they contain, which is biodegradable, so it doesn't, it stays in the environment forever, and we cannot collect it. And these Mardi Gras beads also contain lead, which is poisonous, and cadmium, which I think is also poisonous. These are heavy metals. And you can see this in Wikipedia, in environmental impact of Mardi Gras beads. And on the other hand, you can see in Wikipedia something else, which is glass beads. This is a Wikipedia glass bead making, which is like started at least in the Romance era, which is like 2,000 years ago, and maybe even before that in the Egyptians it started with the clay, which is 3,000 years ago, but at least 2,000 years ago humanity is making glass beads, and it is healthy, and now we can make it into something that saves the environment. Okay, so last question, how is it airtight? Okay, so I'm not erasing everything because I hope I can make it in this corner. How is it air tight? Okay, we know that plastic is airtight. How do we make this airtight? Besides obvious answers like scaling it down so the gaps between the balls shrink and using more than one layer of wrapping, we are used to think about permeability like water percolating into the ground. But the ground particles, dirt grains, do not attract each other like magnets. So it's easy for the water to push them over one at a time. Okay, if we have the ground, okay, and we have a ground grains, and let's say we have a drop of water coming. So this drop of water pushes one of them away, and okay, let's say this one is pushed away. And then the water gets to here. And then the water pushes this one away or this one away. Okay, it's like they are not attracting each other, these ground particles. On the other hand, these ones do attract each other because they are magnetized. They are coming from home from, if you use the demagnetizer, then it collects them and you go and recycle them. But if they are magnetized, like if they fell down somewhere in the middle, okay, then from the truck or something, then they are holding together. They are not like these things, like the ground particles. Okay, so this here, it's easy for the water to push them over one at a time. But this thinking does not apply here, because in pearls, the pieces attract each other, so they are stuck together strongly. So because of the surface tension of the water droplets cannot pass. Okay? We need to understand that the water themselves have water tension. Okay, the water themselves is like attracting the water. Okay, so they don't want to break from each other. So in the millimeter scale or the micro scale. So since these are connected and these are connected, then they cannot pass, the water cannot pass through a layer of pearls. It's not like one tiny droplet of water wants to separate from the big drop, because it doesn't. It wants to stay with the big drop. And here also, the pearls want to stay with the pearl chunk. Sorry. הלו? היי, רק קצר? יופי. אוקיי, אז ביי. אני באמצע. תודה, ביי. אוקיי, sorry. So, okay, so this is not like permeability. This does not apply here. Because of the surface tension of the water droplets cannot pass. the pearls. So, for example, we can use a bottle made from pearls and the liquid will not leak. The only downside is that it will be flexible like a plastic bag and not shapely like the curvy bottle. But its flexibility also means flexibility also means that you can do cool things with it that you cannot do with the bottle, like pushing a straw through it and start drinking, and it doesn't leak because it returns and closes tightly around the puncture made by the straw. Okay, so that's it. So I hope it was clear. That was my invention to replace plastic, and thank you very much. I'll see you in my next invention. Thank you very much. Bye bye.